Let's take a look at items 4 through 6. First, read the instructions. It says for items 4 through 6, tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector. If point C is on the perpendicular bisector, let's say that was the case, that it was on the perpendicular bisector, what would be true about point C? To be equidistant from what? To the two endpoints of the segment. If C truly was on the I haven't even looked at a single problem. It doesn't matter. I haven't even looked at a single one. But I know that if we're trying to conclude that point is on the perpendicular bisector, then I'm going to have to show that it is equidistant from the endpoints. Because in order to be on the perpendicular bisector, it's got to be equidistant from your endpoints. So, looking at number 4, is point C, is that equidistant from your two endpoints of the segment? Yes. So is point C on the perpendicular bisector? Yes. And it's a little weird because it's not drawn. Our perpendicular bisector isn't drawn. But that doesn't matter. So it should be like right about here, if I could draw. Well, but clearly I can't. If it was drawn in, it would look like that. But we don't need this information. We know that if a point truly is on that perpendicular bisector, then it's got to be equidistant from the two endpoints. So yes, item 4, that's plenty enough information to say that C is on the perpendicular bisector. Number 5, point C, is that on the perpendicular bisector? Another way of asking this question is this point right here, or sorry, this segment right here. Is this the perpendicular bisector? Because if it was, point C would be on it, and it would be equidistant from the two endpoints. So do we know if point C is equidistant from the two endpoints? How?
Yeah. Those two are congruent.
So how do you know if point C is equidistant from the two endpoints of the segment? How do you know that? I don't see how you are proving that this is congruent to that. I don't see that.
Okay.
Because in order for a point to be equidistant from the two endpoints, this segment has to be congruent to that segment. We can't prove that right now. Okay, but that's not the only way of proving if a point is on the perpendicular bisector. Maybe you can just prove that this red segment is the perpendicular bisector. If we can do that, then obviously C is on it. So let's take it one at a time. In order to be a perpendicular bisector, it's got to be perpendicular and it's got to bisect. So does this segment here that has point C on it, does it bisect? Yes, it's bisecting this segment because this part is congruent to that part. Is it perpendicular? We don't know. So can we conclude that point C is on the perpendicular bisector? No, there's not enough information. We don't know if it's equidistant from the endpoints. And we don't know if this segment's perpendicular. So, no, we can't. There's just not enough information. We cannot conclude that point C is on the perpendicular bisector. Item 6. Here's point C. We're trying to determine if that is on the perpendicular bisector. If it was on the perpendicular bisector, then it would be equidistant from the segment's endpoints. Be equidistant from the segment's endpoints. Is that shown in our diagram? Do we know that point C is equidistant from the two endpoints?
No.
Is it shown that point C is equidistant from the two endpoints? Are those segments congruent? Is it shown? No. Okay, I don't see any marks of congruency, so no, it's not shown. So, if you can't prove it that way, then the other way that you can prove it is maybe you can show that this segment is the perpendicular bisector, and you'll say, well, I know that this line or segment is the perpendicular bisector, and it's clearly on that. So, is there enough information to prove that this is the perpendicular bisector?
Yes.
Absolutely. Perpendicular bisector. So now, because the diagram clearly conveys that this segment here is the perpendicular bisector, then obviously point C is on that segment. So yes, item 6 there is enough information. So understand the different ways of proving if a point's on it. Item 4, if you can somehow prove that it's equidistant from the two endpoints, then yes. Or if you can just show that you have the perpendicular bisector and that point's on it. That's good to go too. Those are your two ways of showing it. Item 88. Item 88 says use a diagram to solve these problems. It says that segment EH is the perpendicular bisector of segment DF. We're going to mark up this diagram. Which segment is being bisected? Which segment is being bisected? Segment DF is the one that's being bisected. Does it show that on the diagram? No, we have to add that. What's wrong with this? There's already one marks of congruency, so we're going to have to use at least 2. So we've got that this is the perpendicular bisector because the instructions told us that this truly is the perpendicular bisector. So, what's true about point E? What do we know about point E? It's on the perpendicular bisector. What's the implications of some point being on the perpendicular bisector? It's equidistant from the two endpoints of the segment that's being bisected. So that means that this segment is the same as that segment because this point is the same distance away from the two endpoints that are being bisected. From there you can solve this problem. Say that 9x minus 1 and 7x plus 9, those segments are congruent so their lengths are equal. Then it's given to you that this segment's congruent to that segment, so you can set those two expressions equal to one another. Once you have x for solving that, and once you have y for solving that, you can plug x and y into that formula. Go ahead and turn the page. On this next diagram, we're going to add some notes at the top. Again, this page on your, in your workbook, this page, which is 89, Page 89, this deals only with the perpendicular bisectors. This is all about perpendicular bisectors. Just like the other page we just got done with. The POC, which stands for point of concurrency. The POC for the perpendicular bisectors is called the circumcenter. Now this is written in your notes that I've handed out to you, but this is for you and your homework, and so you have it all in one place. What's so special about this circumcenter? Well, the circumcenter is where all the perpendicular bisectors come together and is equidistant from the triangle's vertices. The vertices are just those endpoints of the segments. Because now we're talking about the segments are the sides, so the endpoints of those sides are just the vertices of the triangle. So this page is all about the perpendicular bisectors. The point of concurrency, meaning where these are always, or they're always going to meet, is called the circumcenter. What's so special about it? The circumcenter is equidistant from the triangle's vertices. So it tells us right here that in the diagram, the perpendicular bisectors of triangle ABC meet, meaning they come together, at point G. Right there. What is G called? What give that point a special name? The circumcenter. So you might want to go ahead and add that. At this point G is the circumcenter. What do we know to be true about the circumcenter? It's equidistant from the vertices, meaning it's the same distance away from all three of the vertices. Well, those lengths are being represented by these solid lines right here. So G, the circumcenter, this is the distance to that vertex. G, this is the distance to that vertex. And then from G, this is the distance to that vertex. It is equidistant from the vertices. So what's true about segment GA, GB, and GC? They're all congruent, meaning if one of them is 25, they're all 25. Then it says, so I'm just reading the instructions and looking at the diagram, what are the implications? Then it says they meet at point G, which we know when the perpendicular bisectors meet, that's the circumcenter. It's equidistant from the vertices, we used all that information. And, I can't read it. What does it say? And what?
Are shown dashed.
So are shown dashed, meaning that the perpendicular bisectors are shown dashed. So, this in blue ink, and that in blue ink, and this little guy right here from G to F. These in dashed are your perpendicular bisectors. I need you to mark in that diagram that those dashed segments are truly the perpendicular bisectors. Please mark your diagram accordingly. Show that they truly are the perpendicular bisectors.